Alright, in this question we have elastic potential energy question with on a piece of string which has a natural length of 0.6. We're going to put a mass of 0.4 kilograms. We're going to drop it from this level where it's attached. Now the level of the string is 0.6 meters. It's got a modulus of elasticity of 24 newtons. Now the question is asking what distance will it fall so that its velocity is 1.5 meters per second. This can happen two times. Once as it's falling, it will reach a velocity of 1.5 meters per second. The other time, when the string gets tight and then it stretches, it eventually will stop, but it's going to speed up and then slow back down to a velocity of 1.5 meters per second. Eventually it will stop. So this extra distance after the 0.6 I'm going to call x. That's the stretch. So let's look at the energy in the system. So when it's dropped, there's no kinetic energy. So kinetic energy equals 0. There's no elastic potential energy because there's no stretch, so that equals 0. But the potential energy equals mass times mgh. So I'm going to put m.4 times g, which is 10, so 4. And the distance it's going to fall is going to be this 0.6 plus x. Okay, that's the energy in the system. Now at the base down here, let's just change the color and let's come down here and say kinetic energy will be half mass 0.4 times velocity 1.5 squared. Elastic potential energy, because there's a stretch here, is going to be lambda over 2 times natural length, so 2 times 0.6 times x squared. Now this is going to equal 4 times 0.6 plus x. So let's get this formula, and a half times 0.4 times 1.5 squared, that all equals 0.45. 24 divided by 1.2 is 20. And we've got 2.4 plus 4x. Bring everything to one side, we get a quadratic equation. Minus 1.95. Now x will equal negative 4 plus and minus square root of 4 fours are 16 minus 4ac all over 2a, 2 times 20. So we've got 4 plus square root of 16 minus 4 times 20 times negative 1.95, so we get 172 all over 40. Now that gives us two values. The plus value will be 0.4279. The negative value will be negative 0.22787. Now we're not going to have a negative stretch, so I'm going to ignore this one here. Therefore, it's falling from O to this point, OP, would be 0.6 plus 0.4279, so that is 1.0279. Let's just make it 8 meters. On three significant figures, 1.03 meters. And the other distance was just when it falls. So it drops at 0, velocity is 1.5, acceleration is 10, and its displacement is what we want. And so from these figures, let's use v squared equals u squared plus 2as. So v squared at 1.5 squared equals 0 plus 2 times 10 times x. So 1.5 divided by 1.5 squared divided by 20 is equal to x, and that is 0.1125. So 0.113 to 3 significant figures. And there are two distances where the velocity is 1.5. I hope that this has helped. Until I help you again, stay happy.